Hello everyone, welcome to Chemizon Complete Chemistry. So in our today's video, we are going to solve some of the previous year questions of IIT JAM and GATE chemistry exams. So this is the first question that I had picked up from JAM 2010 paper. The absolute configuration at the two chiral centers in D-ribulose are. So this is a D-ribulose molecule. So if we start numbering from this as a first carbon, first, second, third and fourth, you can see that only the third and the fourth carbon are chiral centers. So in this question you have to assign RS nomenclature for third and the fourth chiral center. So let us see the solution. This is we start numbering from here 1, 2, 3 and 4. So let us see the third carbon. It is attached to 4 different groups, and accordingly I've assigned priority based on atomic number. So from 1 to 2 to 3 it is anti-clockwise, but the fourth priority group is on the wedge. Hence the configuration changes from S to R. So it is 3R, and let us see the fourth carbon. It is again from 1 to 2 to 3 it is anti-clockwise, and hence the absolute configuration is R because the fourth priority group is again on the wedge. So the correct answer is 3R and 4R. That is option A is the correct answer. This is another question from JAM 2006 paper. After the following interchanges of groups in Fischer projection of 2-bromobutane, the configuration of X and Y will be. So here you can see there are 3 molecules in Fischer projection formula. What they have done is, in this first molecule, they have done the first interchange and we get the second molecule. In the second molecule you can see the methyl and the bromine are interchanged. When you see from second to third, you can see that this bromine and ethyl group are interchanged. So this is a beautiful example of the even change rule that we had studied in the first video. Why we did only even changes and not odd changes? So let us see the solution. So this is the first structure here. As we had already discussed that from 1 to, this is the second structure, from 1 to 2 you can see that bromine and methyl are interchanged. That is the first change, that is the odd number of change. Then we further do the second change, that is the even change, and we get this third molecule. So what is important to note is that on doing an odd change you can see the absolute configuration is changed. So on doing an odd change we can see that the molecule's absolute configuration is changed, that is the molecule itself is changed. But when we further do the even change, you can see again the absolute configuration becomes same. This is the reason why we do even changes and not odd changes. So you can see the second molecule, you can see from 1 to 2 to 3 it is clockwise. Fourth priority group is on the wedge, hence the absolute configuration is S, and accordingly for the third structure it is R. So our correct answer is 2S and 3R. That is X is S and Y is R. That is option C is the correct answer. This is another question from GATE 2018 paper. The enantiomeric pair among the following is. So here in this options you can see in every option there are a different pair of molecules. In the first option you can see there is a cyclobutane derivative molecules. Second option is a pair of alene molecules. Third option there is a pair of spiro compounds. So what are spiro compounds? Are whenever two rings are attached by a single point of attachment, that is a single carbon, such class of compounds are called as spiro compounds. And the last one we have already discussed, these are called as biphenyls. So what you have to do in this question is that for every option for a pair of molecule you have to find out the absolute configuration and you have to find out the enantiomeric pair. Means for the two molecules the absolute configuration should be either R and S or S and R. Okay, let us see the solution. So this is the first option. You can see this is the first molecule of the first option. If you rotate this molecule in 3D space, you can see it would look something like this. That is the second molecule. So both these molecules are exactly the same. Even bond connectivity is also same, and hence these molecules are nothing but identical molecules. So this is not the correct answer. This is the second pair of alene molecules. Let us see the first molecule in the pair. If you look this alene molecule from this Deer's point of view, you can see that hydrogen comes on the left, chlorine at the right, hydrogen on the top, and the chlorine at the bottom. So these two groups, that is the chlorine and the hydrogen, which are nearer to the observer, gets the first and the second priority. Accordingly, the groups at the back gets the third and the fourth priority, wherein chlorine gets the higher priority in both the sets of groups as it has got higher atomic number. So from 1 to 2 to 3 it is anti-clockwise, so the absolute configuration is S. Similarly, again for the second molecule, if you look from this cheetah's point of view, you will see that from 1 to 2 to 3 it is anti-clockwise and the absolute configuration is S. So you can see both the molecules have same absolute configuration, hence these molecules are again identical. Let us see this third option where there are Spiro compound. In this first molecule, if you look this molecule from this Deer's point of view, you can see that this carbonyl group, that is C double bond O group on the left, then carbon on the right, groups at the back, carbon on the top, then this carbonyl oxygen at the bottom, that is C double bond O at the bottom. These two groups closer to the observer gets the first and the second priority, these two gets the third and the fourth priority. So from 1 to 2 to 3 it is clockwise, so the absolute configuration is R. Accordingly, let us see for the second molecule. If you look this from this monkey's point of view, you will find that this group, that is C double bond O on the right, carbon on the left, this carbonyl oxygen C double bond O group on the top, and the carbon at the bottom. So 1 to 2 to 3 is clockwise again, so the absolute configuration is R. Remember that these are some class of compounds, that is Spiro compounds or biphenyls, where there is no chiral center but the overall molecule is chiral. So we don't apply Fischer projection formula rules over here. So these pair of molecule is again identical. Let us see the last option. If you look this biphenyl molecule from this dog's point of view, again nitro group at the right, carboxylic acid at the left, this carboxylic acid at the top, and this nitro group at the bottom. These two groups are closer to the observer, hence they get the first and the second priority. Here nitro group gets the first priority as nitrogen has higher atomic number than carbon. Similarly, this one gets the third and this gets the fourth. So 1 to 2 to 3 it is clockwise direction and the absolute configuration is R. So let us see for the second molecule. Here you can again see this nitro at the left, carboxylic acid at the right, nitro group at the top, and carboxylic at the bottom. Again these nitro and the carboxylic acid groups gets the first and the second priority. So from 1 to 2 to 3 it is anti-clockwise. So the absolute configuration is S. So you can see these two molecules are having different absolute configurations, and if you look, you will find that these are mirror images of each other which will be non-superimposable. Hence this is our correct answer, that is these two molecules are a pair of enantiomers. So our correct answer is option D. This is another question from GATE 2008 paper. Match the entries A to D with their corresponding structures. Here you can see in this first section they have given you some names of the systems and then they have given you the options. So bridge system is option number D, which we will be studying later, where these are also called as bicyclic compounds. This middle carbon, single carbon bridge you can see between the two carbon chains. So option bridge system is option S. Or trop isomeric system, we had already seen this trop isomerism is seen in biphenyls. So the answer for option B is R. For spiro, just now we saw spiro compounds are the compounds in which the rings are attached at one point of attachment, that is single carbon atom. So spiro system is option P. And the last one, that is a fused system, that is this option Q, where two cyclohexane rings are fused or joined to each other. So our correct answer should be S, B, R, spiro, P, and fused Q, that is S, R, Q, P. That is correct answer is option D, AS, BR, CP, and D, Q. Correct answer is option D. This is another question from GATE 2002 paper. In alene, hybridization of central and terminal carbons respectively are. We had already seen this type of molecules in our previous videos, where the central carbon is sp hybridized and the terminal carbons of alene molecule is sp2 hybridized. So our correct answer is option C. So here we come to the end of today's video. Thank you so much.